How fragile is our world? Imagine an absolute, all-consuming void, something so massive and incredibly dense that not even particles of light, the fastest objects in our universe, can escape its gravitational trap. The solar system is a fine-tuned, mathematically precise orbital mechanism where planets have moved in perfect equilibrium for 4.5 billion years. But what happens if this balance is shattered by the most extreme astrophysical object known to science? What if, right on the edge of the heliosphere, a supermassive black hole suddenly appears? Today in our simulation, we will conduct an unprecedented experiment. The solar system will collide with a true gravitational anomaly, and in real time, you will witness the destruction of Earth, the death of our Sun, and the annihilation of the giant planets. And spoiler alert, the way tidal forces tear apart Saturn will demonstrate the absolute ruthlessness of the laws of physics. Be sure to watch until the very end. The finale of this simulation will show you what a true cosmic cataclysm looks like. By the way, speaking of astrophysical monsters, it's impossible not to mention the quasar TON 618. It is one of the absolute record in the entire observable universe, a supermassive black hole whose gravity controls an entire galaxy. Be sure to head down to the comments and let me know if you want to see a simulation with this specific giant to test in how many fractions of a second it would swallow our world. Subscribe to the channel so you don't miss that video. And now, let's initiate the doomsday scenario. Simulation activated. A foreign, absolutely destructive variable is introduced into the mathematically precise model of the solar system. On the edge of the heliosphere, far beyond the cold and dark wastelands of the Oort cloud, a colossal disruption of space-time emerges. For this experiment, we haven't chosen a microscopic quantum anomaly or a stellar mass black hole born from a supernova. A supermassive black hole is invading the system, an object whose mass exceeds our sun's by exactly 1 million times. The appearance of a gravitational dominant of this scale instantly rewrites the fundamental physics of the entire star system. To truly grasp the scale of this impending doom, we must look to the foundations of Einstein's general theory of relativity. Gravity isn't just a pulling force, it is the curvature of space itself. Imagine a tightly stretched trampoline with a heavy bowling ball dropped on it. The fabric sags, forming a deep funnel. Our sun creates a small dip where the planets obediently orbit, but a supermassive black hole tears through this fabric. It creates a gravitational well of infinite depth. Every black hole has a so-called event horizon, an absolute boundary, the Schwarzschild metric, the universe's ultimate point of no return. In classical physics, this is the radius within which the escape velocity required to overcome the object's gravity begins to exceed the speed of light in a vacuum. For a black hole of 1 million solar masses, the Schwarzschild radius is 4.25 solar radii. This is a perfectly round, pitch-black sphere nearly 6 million kilometers in diameter. It is crucial to understand it has no solid surface, crust, or mantle like a planet. It's merely a mathematical limit, an optical illusion of emptiness, hiding a singularity behind it, a point where density approaches infinity and the laws of quantum mechanics cease to exist. If any form of matter or energy crosses this invisible line, it will leave our observable universe forever. Even before the planets begin to leave their orbits, the visual landscape of the cosmos drastically changes. A massive gravitational lensing effect occurs. The colossal mass bends the light rays passing by from distant background stars and galaxies. The light literally wraps around this invisible sphere, creating a distorted, blazing halo, the so-called Einstein ring. At a strictly defined distance from the event horizon, a photon sphere forms. This is a unique region of space where gravity is so strong that particles of light are forced to move in closed circular orbits. If a hypothetical observer stood in this zone and looked straight ahead, they would be able to see the back of their own head, because the light reflecting off their back would complete a full orbit around the black hole and return right into their eyes. As time in the simulator accelerates, a total and irreversible orbital collapse begins. The Oort cloud takes the first gravitational hit. This giant spherical shell, consisting of trillions of icy comets and asteroids, is shattered in an instant. Huge chunks of ice and rock, the size of entire Earth continents, are torn from their places. A never-before-seen comet rain, packing billions of tons of matter, rushes toward the new gravitational center. A colossal amount of kinetic energy is released. Next, the Kuiper belt and the heliopause are destabilized. The orbits of dwarf planets like Pluto and Eris stretch into sharp ellipses. Their trajectories turn into a deadly nosedive. As gravitational waves penetrate deeper into the inner system, something fundamental happens. The barycenter, the common center of mass of the solar system, which has always been inside or near the sun, rapidly shifts into empty space. Our star is no longer the master of the house. The sun turns into an ordinary satellite, and along with its planetary entourage begins its inexorable plunge toward the giant. The orbits of ice giants Neptune and Uranus wildly distort, and they begin to fall in tightening spirals. And here arises a crucial paradox of orbital mechanics, one that often baffles people. Why don't the planets just shift to a new, stable orbit around the black hole? After all, it's just mass obeying Newton's law of universal gravitation. Theoretically, you can orbit a black hole as safely as a regular star if you are far enough away. The answer lies in a colossal deficit of orbital velocity. To enter a stable orbit, an object's speed must create enough centrifugal force to perfectly balance the gravitational pull. In relativistic astrophysics, there is the concept of ISCO, the innermost stable circular orbit. For Earth to remain in orbit around a million-mass black hole at its current distance, it would need to move at a significant fraction of the speed of light, tens and hundreds of thousands of kilometers per second. But our planet's current orbital speed is only about 30 kilometers per second. They catastrophically lack kinetic energy. The centrifugal force capable of pushing them away from the singularity simply does not exist. Therefore, they don't enter an orbit. They fall into the warped gravity well along the shortest path, rapidly gaining speed in freefall. The situation is drastically worsened by the effects of general relativity. As the solar system plunges into this gravity well, gravitational time dilation begins to manifest. To an observer in a distant, safe galaxy, it would seem that the falling planets are moving slower and slower until they freeze as fading red ghosts right on the edge of the event horizon. But for the planets themselves, local time flows normally. Another destructive factor is added, the lens-thirring effect, or frame dragging. The spinning supermassive black hole twists space itself around it, like a blender twisting fixed syrup. The planets aren't just falling down, they are being sucked into a gigantic spatial whirlpool. Space compresses, approach speeds rise to relativistic values. Collisions of wandering asteroids at speeds of thousands of kilometers per second generate blinding flashes of X-ray and gamma radiation. Ice worlds evaporate before they even get close to the singularity. All this chaos forms a gigantic whirlpool of scorching matter around the black hole, the seed of a future accretion disk. The outer borders of our home are completely destroyed. The point of no return has been crossed. And now begins the most destructive stage of this experiment, the direct physical annihilation of the rocky planets and our central star. Let's track what is happening to our planet at this very moment. As we approach the singularity, Earth's geometry changes beyond recognition. Hydrostatic equilibrium is shattered. The planet deforms, stretches in the direction of motion, and takes on an ellipsoidal shape. In astrophysics, this destructive process is known as tidal disruption, or spaghettification. Due to the extreme gravitational gradient, the side of the Earth facing the hole experiences an attraction orders of magnitude stronger than the opposite hemisphere. This colossal difference creates tidal forces that exceed the structural limits of any known rock. The planet is literally being stretched apart. Oceans instantly shift, forming hydrodynamic shockwaves kilometers high. Lithospheric plates crack wide open, releasing mantle plumes of boiling magma. The biosphere is destroyed in a matter of hours, and the Earth itself is torn into fragments long before it even crosses the event horizon. Next in line is the central star itself, the Sun. The yellow dwarf, whose gravity acted as the anchor for the entire system, now finds itself in the role of a helpless victim. As it approaches the black hole, the Sun enters a zone of extreme tidal forces, which ruthlessly begin to strip away the outer layers of its photosphere and chromosphere. The star stretches, completely losing its hydrostatic balance. Plasma flows in a massive, blinding stream directly into the black hole's gravitational well. But this matter doesn't fall straight down. Due to the conservation of angular momentum, it begins to spiral inward at relativistic speeds. Because of colossal internal friction and magnetohydrodynamic effects, the gas heats up to millions of degrees Kelvin, forming a blindingly bright accretion disk. The radiation from this process is so powerful that it sterilizes all of the surrounding space. The Sun is literally being dismantled into atoms, turning our system's thermonuclear reactor into scorching fuel for the black hole. But one of the most vivid demonstrations of astrophysical laws can be observed in the orbit of Saturn. The famous ring system of the gas giant ceases to exist, turning into a ring of superheated plasma. This process is triggered the moment Saturn crosses the Roche limit. This is a mathematically calculated radius of a circular orbit, where the tidal forces of the central body, in this case the black hole, perfectly balance the object's own gravitational pull. As soon as Saturn crosses this boundary, its gravity is no longer capable of holding it together as a single object. Billions of cubic meters of ice and rock that made up the rings lose their stability. Mutual collisions at hypersonic speeds generate so much thermal energy that the ice bypasses the liquid phase and instantly sublimates. The hydrogen-helium atmosphere of Saturn itself is violently torn away into the cosmic vacuum, leaving behind nothing but a swirling trail of scorching gas. In just a few months, by the universe's standards, our solar system has been completely erased from the fabric of space-time. The planets, asteroids, and our central star have simply added to the mass of the supermassive black hole, increasing its event horizon by just fractions of a millimeter. Against the fundamental laws of gravity, there are no arguments. If this scientific experiment made you look at the structure of the cosmos in a whole new way, support the simulation with a like and subscribe to the channel. Down in the comments, suggest your own scenarios for future astrophysical simulations. The most liked scientific hypotheses will become the foundation for our next breakdowns. See you in new coordinates of space-time.